Alright guys, we finally made it. This is the very last section in our Calculus 1 class. We're going to be learning a technique for integration called the substitution method. It comes from really the chain rule, you know, your inside function, your outside function. Let's just look at this particular integral for instance. If I was looking at what I thought it might be, I think it has to do something with this, but I know that there's a chain rule involved in that. So f prime of x would be take the derivative of the outside, that would be cosine, leave the inside alone, times the derivative of the inside, that'd be 1/2. And it appears as though this integral is missing that 1/2. Well, that's just a constant, so I could piddle with it a little bit and just say that if this were 1/2 the sine of 2x and I took the derivative of it, I would get that, and indeed I would, plus some constant, so I need that arbitrary constant on there, and this works and it's totally fine, although I'm not always going to be able to just kind of guess and work backwards because our functions aren't and our integrals aren't going to be quite so easy. So this gives us kind of a tidy way of doing a backwards chain rule, and what you'll need to do is look for your inside and outside function. So we're going to be following this procedure here. I'm going to and just do it straight by the book procedure. Let's let u equal that inside function, so I'm going to let it equal 2x. That would mean du is 2 dx. Then I'm going to solve for dx, and that would give me dx is du over 2. Now I can do all of my substitution. Integral of cosine of u, and then dx happens to be du over 2, and that over 2 is just a constant, so I'll bring that out front and I'll have the integral of cosine u du, and I know what that is. That's 1/2 sine u plus c, substituting back in, be 1/2 sine 2x plus c, which is what I got from my trial and error, but this is going to allow me to do more complicated integration. Okay, on to the next one. Let's try a couple with this technique. I see the inside function here and the outside function being to the third. So I'm going to let u equal 2x plus 1. That would give me du is be 2 dx. That means that dx is du over 2. Now I'm going to do my integration. I'll have integral of, I'm just pull this 2 out front because I don't need him right there, and then I'll have u to the third du over 2. Okay, well this will be nice, that'll do that there. So I have the integral of u to the third du. That gives me u to the fourth over 4 plus c, substituting back in for my u because I wasn't given any u's in my original. This would be 2x plus 1 to the fourth over 4 plus c. Nice. Alright, I'm going to say that this 10x is going to be my u. Let u equal 10x. Means du equals 10 dx, and dx is du over 10. Okay, there's what I'm going to do. You know, I had a professor once tell me, mark this out like this and then just call it side work. That way you don't think it's part of your real problem. And it does kind of, I always kind of do that in my head nowadays because I just know that that's not part of the real problem. That's just the side stuff that I'm doing. So I have the integral of 10 e to the u, and then dx is du over 10, convenient that they threw that 10 in there. They didn't really need to, but it makes it handy. So I've got the integral of e to the u du, which that's just e to the u plus c. Replacing my u, I have e to the 10x plus c, because that's what u was. I'm done with that one. Alright, let's try these next guys. I'm seeing inside as being that guy right there, so let me get my side work going here. U equals x to the 5th plus 6. That would give me du equals 5 x to the 4th dx. Okay, that would give me that du over 5 equals x to the 4th dx. Now the only reason I left that in there is because I've got this guy and this guy sitting there. And look how that chunk of stuff is going to be du over 5. It's very convenient. So here's my side work. If I have the integral of, now let's do our substitution. I've got u to the 9th x to the 4th dx is du over 5. Okay, I can do this. This is going to be 1/5 times u to the 10th over 10 plus c. It's going to be replacing x to the 5th plus 6 raised to the 10th all over 50 plus c. Okay. The next one, I want that to be u to the 3rd, so I'm going to let u equal, side work, we're going to let u equal cosine x. Therefore du is going to be negative sine x dx. And I'm going to go ahead and just say negative du equals sine x dx, because I have at my disposal a pretty little sine x dx there. So now I'm going to do my substitution here, and I'll get the integral of u to the 3rd and times negative du. This is going to be negative u to the 4th over 4 plus c. So this thing is just, let's put it down here, negative cosine 4th x over 4 plus c. Okay. Well, messy again. Let's let u equal x plus 1. Got an x right there. So let's just say x equals u minus 1, because that's what it equals, and I got this x up there that's going to kind of freak me out a little. I also know that du equals dx in this case. Take the derivative of both sides there. So here's my side work. These are the things I need in order to do my substitution. So I've got the integral of u minus 1, and that is u to the 1/2 power du. I'm going to bust this apart. So this is going to be integral of u over u to the 1/2 is just u to the 1/2 du minus integral of u to the minus 1/2 du. Finishing this up, adding 1, so this is going to be u to the 3/2 over, and that 3/2 would have come down front, so it actually goes here, which means it actually flips, minus, Adding 1 would be u to the 1/2 over 1/2 plus c. Getting my constants and everything straight. This is 2/3 and u is x plus 1, so square root of x plus 1 quantity cubed, I'm just doing it to the 3/2 in that fashion, minus, flipping that 1/2, that's a 2, square root of x plus 1 plus c. Okay, what we'd like to do now is kind of make it look like their example. This is a fine answer, but we like to make it look like theirs. So this is to the 3/2 power, so if I pull out this x plus 1 to the 1/2, what I have left is this 2/3 times x plus 1 to the 1, because 1/2 and 2 over 2 is 3, minus 2 plus c, leaves me with x plus 1 to the 1/2, 2/3 x, that's plus 2/3, and then so plus 2/3 minus 2 plus c, and I get x plus 1 1/2 2/3 x, that would be a minus 6, so it would be 4/3 plus c. They saw a 2/3 in here and pulled that 2. Let's go ahead and do it just so that we can make that the same. So 2/3 x plus 1 1/2, and that would just be an x minus 2 plus c, and that's how they got to their answer algebraically. Okay, we're going to do the substitution rule used for these definite integrals. I see the inside function as being this u equals x plus 3, therefore du equals dx. Now when x is 2, then u would be, so my limits of integration aren't the same because I'm changing this to u's. So when x is 2, u is a 5. And when x is 0, u is a 3. So in order to have this in terms of u, I would have to change those limits of integration as well. What I have is u to the minus 3 du. This would give me, adding 1, u to the negative 2 over the negative 2, evaluated from 5 to 3. Alright, so one thing that you could do at this point is you could go ahead and crunch it all out and get your answer, or you could leave it in u and then go back in terms of x's and then do your final computation. Either way will get you what you need. So I've got 1 over, and this is going to be negative 2 times 5 squared minus 1 over negative 2 times 3 squared, and crunching those numbers you'll end up with 8 over 225. Okay, play again. Let's let u equal to x squared plus 1. Therefore du equals 2x dx. Notice that I have this x dx, so I'm going to say that du over 2 equals that x dx, so that I can just plop that in. Changing my limits of integration, if x is 4, u is 17. If x is 0, u is 1. And I would have 1 over u, and then I would have this x dx is du over 2, so that du over 2, pulling that 1/2 out front, and whose derivative is 1 over u? Well, that would be the natural log of u, evaluated from 17 to 1. Chunking those numbers in my calculator, I'll get that for you. Alright, we end up with 1/2 natural log 17, which is going to give me about 1.417. Okay, that's the answer to that one. Next, I want this to be u to the 4th, so I'm going to have u equals sine x. That way du equals cosine x dx. And I'm sitting there with a cosine x dx, pretty as you please. My limits of integration, when x is pi over 2, that's a 1. When x is 0, that's a 0. And I'm going to have u to the 4th du. So this gives me u to the 5th over 5, evaluated from 1 to 0. This little guy is just 1/5. Alright, almost done. Here we go for integral of cosine squared theta. This one's going to be a bit tricky. So if I let u equal to cosine theta, du is actually going to be minus sine theta d theta. And I don't have one of those guys sitting there now, do I? So I've got to figure out, well, what am I going to do with that? Alright, what I have to do is I have to go and get my identity, because this just isn't going to work because I don't have a sign there. But if I can write it so I don't have that square, then it would be much easier. So I went back and got my trig formula for you, because this one would be messy. So I could say that this is pi over 2 of 1 plus cosine 2 theta all over 2 d theta, just using a trig identity. Then I can break this apart, and I can have the integral of pi over 2 0 of 1/2 d theta plus, I'm just going to put that 1/2 out front on that one, of pi over 2 0, and just write it as cosine 2 theta d theta. Alright, now this I can make go. So that's just going to be 1/2 theta evaluated from pi over 2 to 0. I can do that. Plus, using that chain rule, and actually the very first problem that I did, I found out that, oh, there's that 1/2, he's already sitting there, so that's just really sine of 2 theta pi over 2 evaluated from pi over 2 to 0, because if I take the derivative of this, it would be 1/2 cosine 2 theta, which is sitting right there. And then I just do the computation of plugging this in, and I'll get that for you. Alright, just plugging those in. This would be the sine at pi, which is 0, the sine at 0, which is 0, and all these guys go away, just leaving me with just this 1/4. And that concludes all of the content for Calculus 1. It has been a pleasure, guys. And if you have any questions about this, hopefully you'll email me or see me at the Collaborates. Thank you.